So it looks like it is it's time, 4 o'clock or so. So let's go ahead and get started. Welcome to the first of 4 sessions preceding the 2013 Neuroethics Society conference in bias in the academy from neural networks to social networks. So the conference, the symposia, is an annual event in which we discuss issues at the crossroads of neuroscience and ethics. This year we're looking at issues of biases in academic settings. So some background, last year there were some interesting communiques from the university, from higher ups, particularly President Wagner ended up making a social gaffe, inadvertently validating slavery and the merits of it with his 3/5 compromise comment. Before that, there was also another strain of emails talking about the issues associated with women in neuroscience not being pretty enough. And these are not new. These are not something that are out of the blue. Perhaps with the movements broader in America proper, having the first non-European president, we're looking more into having a discussion, an open discussion of these issues, and perhaps it's just my own youth that I'm seeing these things happen. So here we are, looking at the crossroads of neuroscience and social biases, prejudices. So in this workshop, I encourage you to ask questions often, make statements often. It's intensely collaborative. I'll throughout this want you all to get into some small groups and start discussing with yourselves some of the issues. There's also the opportunity for live feedback. So if you text message to this number with the opening 6-digit string and whatever you want, you can put your comments live onto our live feedback feed. I'll go ahead and demonstrate. So opening up my phone, it's got pretty good reception in here. Right. So let's see. And we'll type in 988-586 and hey everybody. So if you have any comments, any thoughts, anything that you want to share during the course of the presentation, go ahead and post them to the board, and we'll field those throughout the course of the presentation, or throughout the course of the workshop. So, in case people get really excited about it, and you start receiving, you can't actually send the message anymore. There are 2 additional numbers. So at this point, actually, I encourage everybody to rouse up, grab their cell phones, and go ahead and send the initial message, and we'll see how that works. So we'll take that 2 minutes. And please, I guess at the same time, there's food back there, so go ahead and grab some food if you feel like not having food go to waste, like eating fresh food. So as not to waste time, we can go ahead and catch this video I prepared, which is kind of nice. And talking about human knowledge, we're great people. We've got this human creativity, we've got this ability to create to make more than one thing out of a single object. Take the example of, say, just a potato. People are fighting over potatoes, and you learn how to cook it, and suddenly becomes nourishment for, multiple people. And so with this human knowledge, we've got so much that we can do, so much that we can make, so much that we can explore in order to enable humanity to live well with one another and live joyously. At the present time, at Emory University itself, there's a paucity of diversity. The representation is, the diverse representation is rather low. If you look at the bottom of the screen, you'll notice the exact number in terms of diverse individuals in full-time faculty positions is 9.8%. And the rest of the individuals are from Europe. So that can be improved. If we look at Atlanta and Georgia, even the United States, and the figures in the previous graph, we're looking at this number down here, the white non-Hispanic. So that's the one you want to pay attention to. In Atlanta itself, there are 30% of the population is white non-Hispanic. And yet in the university, we were seeing that 80% or 90% of the tenured faculty are white non-Hispanic. So there's plenty of room for improvement. In Georgia, it's 50% in the U.S. in general, 60%. And we look at the world itself, which is what we're trying to build towards, to build a university that's truly representative of people's diverse mindsets, so as not to suffer the issues of pigeonholing our ideals and looking at only particular tracks of thought, such that we can invest our minds in the creative spirit that is the fullness of humanity. Rather than doing things that are antithetical to this principle of human achievement, human creativity, and human growth, human prosperity. We look at women as well at the university, and there's a similar imbalance, whereas throughout all sectors of the globe, local and distant sectors, there's around 51% of the population are women, 49% are men. We see that at Emory itself, 2009 to 2012, 75% of all professors were men. So we miss a lot. We miss a lot when that happens. We miss perspective. We miss, as we'll see, the types of unique qualities that are distinct to each of the sexes. And that's something that can and should be improved, lest we feed upon a notion of bias being a good thing, of sexism, racism being good things. All right, so to the video. Did people do this thing? There we go. Yes. So test from an anonymous number. So here it is. One more time. Take the number down. If it welcome on. Take the number down if you're interested in doing this. You'll see it happen. All right. This is also a way to record the information from the workshop. So back chatter, as they say.
She's an advocate for girls' access to education worldwide, is the youngest person ever to be nominated for a Nobel Peace Prize. Her new book is called I Am Malala, the girl who stood up for education and was shot by the Taliban. Please welcome to the program, Malala Yousafzai.
And in my opinion, the solution that would work to fight all these wars and all these problems that people are facing is only education. Because you can stop war for a second, but you don't know it will start again or not. We have seen First World War, we have seen Second World War, and I think Third World War is coming. But I believe that we must stop it now. I don't want to see a Third World War in this world again. And the best way to fight against this war is education, because as we can see that children are suffering from terrorism, they are suffering from child labor and child trafficking. They are also suffering from the cultural norms and traditions. There is not only one issue that we are facing through, there are many others as well. So I think education is the best way. People would be thinking, just going to school, learning about chemistry and physics and maths, and that's it. Going to school is not only learning about different subjects, it teaches you communication, it teaches you how to live a life, it teaches you about history, it teaches you about how science is working. And other than that, you learn about equality, because students are provided the same benches, they sit equally, it shows us equality, it teaches students how to live with others together, how to accept each other's language, how to accept each other's traditions and each other's religion. It also teaches us justice. It also teaches us respect. It teaches us how to live together. So that's why I support the idea of sending children to school, because it is the best way to fight terrorism. And I want people to support us in this cause. And through Malala Foundation, we want to work for education of girls in the developing countries, especially in Syria now. They are suffering, they are homeless now. We want to help children in Afghanistan because they have been suffering from terrorism for decades. We want to help the children of India as well because they are victims of child labor. So I think issues and problems are enormous, but the solution is one that is simple, that is education.
Okay, yeah, so this is the perspective, you know? You have people everywhere throughout the world, here in Atlanta, in Georgia, in the United States, in Afghanistan, the smallest reaches of the planet, looking towards human achievement, the ability to make something of life, to build a better future through growth in education, academia, creativity, the human drive towards making multiple things out of something that was initially just a single thing. So I ask, why is knowledge important to each of you? And I ask that not as a rhetorical question. And so this one actually works. These have been working together. Yes, so these work. So I'll pass this around, and we'll. All right. So thanks. All right.
Good afternoon. I think knowledge is important to me because it helps us to be able to connect with others. I think that it helps us to challenge ideologies that we might have.
So for me, knowledge is important because it allows me to make decisions for myself rather than just listening to what other people think I should do, or just following, I guess, the beaten path, or allowing other people to make decisions for me. I think a lot of the things that happen to people just for lack of education, so knowledge provides that for me.
This is a tough question. I like it though, because I've always wondered, what is it about school? What is it about going and learning about things that actually engages me? And I think part of it is maybe from a neuro perspective, my brain likes to be excited, right? But on another level, I always saw knowledge as us learning how similar we all are, how much we all have in common, what problems we all have in common, what challenges we all have in common. So knowledge it really is that, someone mentioned it before, but that communication. how to connect with each other. It's really the way we connect with each other, knowledge and communication.
I think for me, why knowledge is important is because it provides understanding, and kind of in the context of like my past, present, and going on to the future. So I can just appreciate knowledge because it allows me to understand pretty much everything we're through.
Yeah, these furtive movements, let's make them into actionable things. Call it the seats are supposed to be in the round, but
Anybody?
and just leave that there. There are like 5 mics up here. So. Oh, actually, we can. There's another one of these that works, so put one on there. So,
I think that knowledge helps us to have a richer experience in life because we get to, for me, knowledge lets us experience more and it opens up horizons for us. Also, it helps you to make more money, usually. And that's good.
Should we alternate from side to side, or
you gotta hit the top button. There's a top button.
like that? Is it? Oh, I probably have to talk quieter than I normally do. But I think one thing in academy most people understand is that knowledge gives there's a kind of joy to it. That learning new things is almost addictive sensation. It's almost like gamble, like pulling a slot machine or something and the numbers coming up, and it's almost like that, how learning new facts and doing science to perhaps create new knowledge too.
I think that knowledge not shared is bordering on narcissism, but knowledge that is shared is the baseline of the human experience.
These are great answers. I'm just coming in, but I'm assuming I'm talking about my knowledge is important to me. Just to add to everything else, did anyone say knowledge is power? Yeah, it's a cliche, but and knowledge is often about survival. You know, how do you, knowing the world around you and being able to navigate the systems around you is a way to survive in those systems.
Oh, okay. So we are saying why is knowledge important? Okay, I just have personally, I have a very inquisitive mind. Acquisitive, not as much inquisitive. I just want to know everything, which is why I keep trying to read books on theoretical physics, even though I don't understand them at all. And I would agree also with the idea that learning is very much an addiction, and that knowledge is power. So the more that you know, the more that you can, the more effective that you can be in navigating power structures and navigating and getting things done.
Okay, I think everyone's covered a lot of things. I don't know if I have anything super exciting to add. I was going to say that, I mean, I've heard other people say this, that one of the exciting, people mention that knowledge is exciting, and I think one of the things that's exciting about it is you're always kind of pushing the envelope of the boundary of what you know and what you don't know, and I think what drives a lot of people in science and also in the humanities is trying to understand what they know and what they don't know. So that's one of the things I like about knowledge.
Saying something original at this point. I guess I would say that I think that the most important things about human life are the true, the beautiful, and the good. And it seems to me the true is the most fundamental of those because it is the foundation for the other two. And knowledge is about ascertaining the truth.
say it's more knowledge makes understand more about myself, and I understand more about myself. Yeah.
And knowledge can bring us understanding to the world. The much you know about it, the bigger challenge that you want to know much about it, and it brings imagination, also brings us pleasure to enjoy the process to know something, and also is a good exercise to our brains.
Well, that's really great. Yeah. Let's actually give ourselves some like ovational stuff. I like ovations, doing some really ovational qualities to this, enthusiasm, all those things. So yeah, I agree. I think we have a similar thought pattern as far as what it means to use this brain that we have, and do something with it. And that's what everybody who's interested in this conference is thinking about. How do we make it such that more people can enjoy this fruiting of the mind? So how does the brain make knowledge? Yeah.
I see one thing real quick.
Yeah.
I realized you said I'm tweeting this event, so I tweeted some of your responses. Okay with everyone? I may continue to tweet, so just.
Oh, yeah, and there's a camera. If people are messed up with that, I'll turn it off. Okay, right. So yeah, how does the brain make knowledge? Is everybody, are there people, I see a lot of people who have neuroscience background. Are there people who don't? No. Okay, right.
Humanities over here, so you guys like slow.
Perfect. All right. So it is a neuroscience primer, and in that sense, we're going to go through Neuro 101 kind of stuff. Yeah. Huh.
That brain was backwards.
Yes, and that was a free image, actually.
By design, you're trying to get us to think away. Sorry, that just appreciate it. Yeah.
It looks great.
It does. It has all the characteristics except for the right symmetry. I don't know. So from development, human beings are in gestation or born. It's actually really interesting that the first structure that's created or that's built, that's made, that's differentiated within the egg itself is this neural plate and the neural crust and the beginnings of this neural tube that creates the spine, that creates the spinal cord in the brain. In this, the ectoderm, that also becomes all the nerves and the skin. Everything else, sort of differentiates later, becoming, muscles and bones, and also the enteric system, all of these intestinal qualities that are connected to the yolk, and so on and so forth. So, to have that communication early, that ability for the organism to communicate with itself and to sustain aware processes that control the organism and enable it to navigate within its environment, developmental environment at this age, is very important. And so we see that this development of the nervous system goes through all the different stages. As you've seen in the previous slide, it's about 3 weeks. So as it goes through the different stages, it starts to differentiate into these, initially 3 different areas and moving into around 5 later on. These areas are typically defined as such in the embryonic stage. Moving from this frozen cephalon, you don't need to know these things. It's really sort of, sort of just something for people who are into it. But to know that you've got these different regions of the brain organizing along the stages of development is actually pretty interesting. A cool evolutionary thing that people start to see in this developmental stage is that the development of the organism passes through the evolutionary tree, where you have really very simple structures that organize very simplistic activities at the early stages of life. These areas that are communicating on the spine, that are developing sensory input, output, methodologies in the thalamus, and so on and so forth. These end up differentiating still further into the cerebrum, this part of the brain that is very distinct for the human being. On these crenulations that become areas where real thought, where associative thoughts are occurring. So you know that. A little anatomical phraseology at this point. When talking about the anatomical structures, you'll oftentimes hear people referring to it, to these different areas in this rostral caudal type of jargon. So let's look at this one first. The dorsal, think of it as like the dorsal fin, corpus, it's on the back. The rostral, the rostrum coming into the room, and the caudal and these tails, so that's at the end. On a human being, rostral caudal, the rostrum where you go into, that's directly in front of the individual, the caudal being the tail is directly behind, dorsal. In this case is on the top of the head, because most of these anatomical regions are defined based upon four-legged creatures, and so if the human being were not standing upright, it would have its anatomy positioned as such, where the head is actually looking up, and the top of the head is facing where the back is. So that's often defined as the dorsal side, and the ventral side being towards this neck area. And you see it in the same orientation in the neck itself, where the bottom of the neck is the ventral side, the chest area, the stomach. These are some other sections to orient yourself, dorsal, ventral, same as you're seeing in the neck and head. If you're looking at section planes, so horizontal, is just horizontal. Coronal comes from crown. I guess people like to put crowns like this, so I'm not actually sure why. Sagittal from arrow, so like Sagittarius, so something straightforward. So hopefully that'll enable you to navigate some of these phrases. Right, so the adult macroscopic brain organization. So it's really kind of cool how this works, as we're seeing with the development in utero, going from earlier life to earlier life in the evolutionary chain that created human beings, that came to human beings in this day. There's a similar nicety to the organization of the brain here, where you're seeing a lot of the sensory information routed through the spine and coming up to this medulla structure, and the midbrain as well. So you get a lot of the sensory information from towards the top of the head, going towards the midbrain here, the ears and the nose and so on and so forth. And then a lot of the information from the rest of the body coming up the spine and interacting, synapsing in the medulla, going into the pons, and especially since it's a lot of motor information and information from the rest of the body, being passed into the cerebellum, where a lot of motor activity takes place. It's this other structure just in the back of the head that seems to be doing its own thing. It means the little brain. And it's really just sitting there organizing fine motor movements and enabling people to learn new motor skills. Now autonomously, it's kind of interesting. People don't actually have a conscious sensation of what the cerebellum is doing, and yet they're making use of it in much of the day-to-day activities. Everything then gets routed into the encephalon, which is the thalamus and the hypothalamus, which is the doorway to the rest of the brain. The thalamus itself takes in a lot of these sensory information and passes them into the cerebral cortex that then goes through these associative paths and talks back and forth. We'll get into that in just a sec. Whereas the hypothalamus ends up interacting with a lot of the endocrine systems and sending out chemicals and through the pituitary gland, growth signals, and so on and so forth. So it's a really something that perhaps it's the fact that we're built this way that it makes sense to us, but it really does make sense. And so we have a couple of different the lobular structure, and these names are just based upon the bones that are around there. But a frontal lobe, which is all this executive processes, the top-down processes that people tend to think about, how you consciously organize your activities. Temporal lobe is associated a lot with speaking and hearing, and it's also associated with relating to other individuals. And this has been found in some research. Parietal lobe is an associative cortex that integrates a lot of the processes from the rest of the system, a lot of the sensory processes, integrates them into a single type of code that then gets sent out to other areas of the brain as an integrated sensate. The occipital lobe, directly behind the eye, is where the visual information comes in and projects itself onto the back of the brain. And it's kind of interesting. In each of these areas, there's a spatiotopic mapping of the sensory organs themselves. If you look at the visual field and where things are located in the visual field, that same mapping is reflected onto the occipital lobe. There's also spatiotopic arrangements here at the central sulcus, and we'll get into these in more detail. M1 as supplemental motor area. So M1 is interacting with your body itself and enabling and sending down the descending motor commands, whereas the supplemental motor area is providing for more movements that are not as simple, so more elaborate movements and learning of those things. And as I was saying before with the spatiotopic map, each of the parts of the body are arranged spatiotopically onto the motor cortex. You'll see each of the digits of the hand in a hand structure. In the motor cortex, you see the tongue, each of the motor areas of the tongue, and the lips especially, in a unique structure in the motor cortex. So that's the brain. And the cool thing about this is that it's organizing each of these qualities of life that we recognize in our day-to-day. It's taking place here, and you can find a representation of a lot of it going on in the brain. Search. You'll find So going into the cellular organization within each of these systems, as I was mentioning before, there's let's just take the motor cortex for instance, you've got this layer of cells that are organizing themselves into layers in order to communicate back and forth the information that's being sent to it via the sensory systems and other systems. And, yeah, these are arranged in such a way so as, let's say for instance, you wanted to send information to the spinal cord through the pons and the medulla through one of these pyramidal cells. Information coming up from the thalamus would end up synapsing with this area in the motor cortex before it sends its command back down to your motor units. And the same takes place for information going ipsilaterally, that's on the same side, on the same lateral side, or contralaterally from information on one of the brain sides. And I guess it's just to get into that, the lateralization of the brain. There are two lobes, so human beings are pretty much split into two hands, two eyes, and two sides of the nostril, so on and so forth. And the same type of mapping is represented in the brain, typically crossed, perhaps evolutionarily in order to enable people to still do something on the right side. There's like some sort of tiger or something that hits your brain on the right side, you can still do something with it over there and still maintain that ability to have that as a defensible act. And yeah, so in addition to these communications across the regions of the brain, from different areas in the diencephalon, and so on and so forth, you've got these other that are generating excitatory, and we'll get into that, this difference between excitatory and inhibitory. You've got these inhibitory cells that are synapsing at different parts of the system in order to put the brakes on what's going on. So it becomes this really dynamic circuit of information being passed from different parts of the brain throughout the whole system, and also these cells that are enabling checks and balances for the information flow. So yeah, this is the neuron. At the microscopic level. You got a nucleus and dendrites, cell body, and this is a really typical one. They come in all a whole range of types and arrangements of dendrites, and as we've seen before. In this one, you're seeing some myelin. Probably not going to get into that in the conference, but there it is. The myelin is a sheet that's preventing the information that's being sent from the cell body of the axon hillock through the axon itself and to synapse at the axon terminals with the next neuron, preventing this information that's chemical in nature from escaping out and diffusing into the rest of the system. And so I want to reiterate that that's how information. And one of the ways that information flows, one of the most typical ways that information flows, you've got a set of dendrites here that are receiving a chemical signal, and a chemical signal in some instances glutamate, the excitatory signal that we had mentioned before, in some instances this GABA, that's the inhibitory signal that was also mentioned. So this chemical release at the axon terminals, being picked up at the dendrites and these receptors, ends up sending other chemicals. In this case, sodium ions, into the cell, depolarizing it and causing other cells in the system to have this depolarized state. When a sufficient depolarized state is reached, it will send an action potential to the next cell. And so that's really how it works. You've got, at the smallest level, these chemical messengers contacting with proteins and sending in other chemical messengers until a sufficient amount of information is reached that it sends the information to the next neuron. You can also have these that send in a negatively charged ion that inhibit them. So the two processes creating this huge net of information that does all kinds of things. That does all this conscious activity. Let's put it all together, flip in one of these things. To get to the idea of how the change actually takes place, because I know that was a lot of information.
Hit this song.
When we learn a new motor skill, the brain undergoes a number of changes. fMRI studies show blood flow increasing to large areas of the cortex involved in the task. The excitability of neurons distant to these regions heightens. And after weeks of practice, certain cortical maps representing the body parts being used enlarge to include adjacent, previously uninvolved areas. These findings suggest a process we call plasticity, the brain's ability to change in response to our experiences, its ability to learn. The supplementary motor area, also known as SMA, and the primary motor cortex, also known as M1, are the main areas involved in task learning. A highway of neural connections carries information from SMA to M1. However, many of these pathways are inhibited by signals from local GABAergic neurons that synapse densely around pyramidal cell bodies in M1. But disinhibition can occur. With focused repetition of a motor task, high-frequency activity is induced in thalamic projections to M1. And if input from SMA arrives at the same time, these inhibitory signals to the excitatory pyramidal cells of M1 diminish. Pathways once latent now activate the caudal part of SMA. And as practice of the task continues, activation spreads to the rostral area. Meanwhile, changes are also taking place in M1. Within M1, sprouting at axons and dendrites creates new synapses, or strengthens existing neuronal connections, resulting in greater complexity of the affected neuronal network. Those pathways less used may be weakened through long-term depression, while those used most frequently may be strengthened through long-term potentiation. Several weeks of practice reveal growing representations of the body parts being used. Their boundaries, once considered static, begin to show overlap. As proficiency at the task increases, unnecessary neurons become inhibited. Cortical areas in M1, once enlarged, shrink to optimal sizes, and activation in SMA decreases. The brain is finding the most efficient use of space and neurons, and the student is learning to master the skill.
Cool. Yeah, so that's in action how it works. You've got this communication. Different areas of the brain start communicating differentially with other parts, developing different synapses, different arrangements of neurons. different qualities of information flow, and pruning others as people learn and take in new information. And so this is the process that's continually taking place as we live and learn. Okay, so hey, yes, more discussion questions. Right, so some of the interesting things to think about are these questions of, you know, who we are. What does it mean to be a person with a brain? You know, how does it enable the behaviors that we have? How are we limited by the fact that there are only some structures in here that we have eyes, but we don't have like eyes that can see infrared? How does that limit some of the qualities that are human qualities? And so what is this dynamic reach of humanity? Yes, so where did those microphones go? Sweet. But yeah.
I have an informational question. I'll get into that. So you're saying that regardless of whether we're learning motor skills or like the information about the brain, it happens the exact same way?
Yeah, pretty much. I mean, the thing about the motor skills is that it's the easiest to experimentalize. I mean, you can see somebody moving their hand, and so you can write it down, they move their hand, and then you can check it on in the brain. So a lot of the stuff that is foundational are within particular systems, like the motor system. So, I mean, certainly there's the possibility that there are exceptions. People don't know everything about what's going on with the brain, but that's how it works. And you see that general principle.
I had a question about when you were talking about the duality of the body. Is there a way that the duality of the body and the brain, I can't remember the word that you used, but creates dualistic thinking?
Yeah, kind of. So, I mean, it kind of goes back to that left brain, right brain thing that people got into. And there were some experiments going on, like in the 60s, 70s, where people were trying to find out with epilepsy patients how to cure epilepsy. And what they were finding is that there was, this spontaneous electrical activity going from one spot and causing the whole brain just to go haywire. And so they severed a part in the middle of the brain that connects the two lobes. And from that, they started to do these experiments, split brain experiments with individuals to see what information is happening on each side. A lot of right-handed people, they typically originate speech acts from Wernicke's and Broca's areas in the temporal lobe, these temporal lobe areas. They're speaking with people and engaging and hearing and speaking. And so if you were to show them something on a side of the brain that didn't send information to where their centers of speech were, so if you showed them something on the right eye, and the information from the right eye was only going to the right lobe and not contacting the speech centers on the left side, then they couldn't, with their speaking center, see what was presented to their right eye. And in that case, I suppose they would have to have cut something else, but just in this case, they wouldn't have been able to see with their speech centers what was presented to the eye that was on the opposite side of their speech centers. And so in that case, they couldn't say it. And they started to do some other experiments with mathematics, with creativity, with drawing and so on and so forth, and finding that typically people were better at doing one or the other activity certain sides of their brain. Future experiments have debunked that. And experiments that are looking at informational flow through the brain, connectivity patterns, processes of these like ipsilateral, contralateral connectivity patterns. In fMRI experiments, they're finding that the information as a whole is traveling throughout the course of the brain, and that you use it all. So is there specific, like, are there specific parts of the brain that do specific things? Yes. But, I mean, is it concentrated on one side or the other? Not with well-defined, in a normal human being, not with any well definition. And then if people were to continue to learn, they would start to, after that fact, they would start to compensate for this inability to speak with things that are presented to only one side of their brain. And I just wanted to correct myself in saying that there's something about the crossing of the eyes. If you're not shaking your head, then it doesn't really matter for you right now. So, right.
So just to build up a little bit on that and addressing sort of that first point, I think one of the most striking things that I learned was this idea of some people have, after strokes, hemi-neglect, spatial hemi-neglect. They're completely unable to really realize one side of their existence. They see it, they don't realize it. And
What does that mean?
That's a great. So you see these patients and they'll walk around and they'll put something in front of them on the right side and they'll be like, walk, and they can see it, right? Like if you tell them to focus in on something, they'll be able to see it. But if they're just walking, they'll bump into it. And it's bizarre because then they look at it and they're like, oh, if you turn their head and it's sort of done by the other side, they're like, oh, okay, it exists there. But before they wouldn't have mentioned it. The cool thing about this is actually, I think it's, pretty sure this is right, correct me if I'm wrong, the left side of the brain projects to, sort of takes care of left and right a little bit. But the right side of the brain only takes care of the left. So that, for right-handed people, for the majority of people. So that if you have a stroke on the right side, you have this hemi-neglect on one side. But if you have a stroke on the other side, well, okay, so if you have a stroke on the right side, your left side still handles the left side, so you're fine. If you have a stroke on the left side, your left side handles both of them. So you lose your right-sided one. So having a stroke directly affects your behavior in a way that it's not obvious. It's not that you're blind in that area. And obviously this is a subset of people who have strokes in that specific area. There are specific areas that are responsible for attention on the right side. But like that's this fascinating idea that if you have a stroke in a different region, maybe you're just incapable of happiness, or you're incapable of compassion, or you're incapable of moving, we're familiar with that, you're incapable of moving your hand. Those are very real things that we see in the news, we see all this, but this other side of stuff, we don't really see. People are just, they have a stroke and they're just unable to be ethical. Like that's like, I think that's, not to be an apologist, not to like wave away that kind of stuff, that's a whole different discussion. But the idea that the brain and its health and its integrity and where things are wrong really directly affects human behavior. That was one of the sort of like, and that hemispatial neglect was one of the weirdest things to really encounter this kind of level eye, because it's not the same on both sides, but at the same time, there's an elegance to that circuit. It's not like the left side, right side's creative, left side's whatever, but it's you look at the circuit and you see, okay, you take this out, you kind of forget about one half of your world. So just to build on that's how I think the brain really shapes that human behavior, by taking specific components of it and affecting how it gives rise to larger behavior.
And kind of to add to what you were talking earlier is like just thinking about vision, which is like one of our major sensory systems that we all rely on for the most part, is something that Jacob mentioned, is that we only see a very small spectrum of light for photons that are out there. And it's amazing that, again, there's other animals that see different ranges, but we really are only aware of and reacting to a very limited range. And that's kind of a very interesting thing to consider. I mean, we forget about it because, again, we're reacting to vision all the time and we think we know what's going on, but reality, we're only playing in a very small range.
Yeah.
I don't know if this is a place for this question, but, so, what is the like current idea on how what we just saw creates conscious thought?
Do you mean subjective experience or the ability to, kind of this idea of executive function, the ability to like executively make decisions? Those are two kind of different things. The second.
The second one.
Yeah, I mean, like, that is the $1,000,000 question. Yeah, that's the hard question of neuroscience. Like, with all of this stuff, it's working, it's doing it well. Like, how do you then take a step outside of that and say, okay, now this is the point at which all of these things make this conscious experience? It's a really, I mean, philosophically, experimentally, and it's a really difficult question. Yeah.
Yeah, I would comment, there was this French researcher, I think in the 70s, who did some work on that with patients who had really large frontal lobe lesions, and that's a pretty rare subject to come across, so we don't know a lot about it. And I don't know, apparently people thought he was sort of a crank, so we don't hear him referenced a lot. His last name was Larry. But anyway, he had 2 papers about, I think, kind of what you're getting at about executive function in these patients. And I think specifically they had very large left frontal lobe lesions, and he remarked through a series of like little tests that he set up that these patients would engage in acts that didn't seem to, but they didn't seem to be making a decision about engaging in acts. So for example, for the woman he put out, and this is like very, talk about bias and then he put out like a makeup set for her to play with. He didn't say anything, he just put it out. And she was in his home, I believe, and she just sat down and started putting on makeup. Now no one would do that, but it was sort of like he put out little things that she did with the mail, you know, just with the mail he put out a gun and some bullets. The guy started loading the gun, he just stood there and was like, then I stopped Easter. But another time he told them that his apartment was a museum, and they went around and looked at all the paintings and made comments on them. So, which is just very strange. So and it's a really unsettling set of papers, but I think it highlights, you know, where decision making, how many layers are in decision making, and how it's like decision making involves like, you know, involves things about when something's appropriate, when you should be doing something, and even though, you know, anyway. I don't know, but yeah, it's a philosophical problem for sure. But I think that his papers got at it a little bit.
From my general knowledge, from working with networks thought to be associated with consciousness and such to some extent, executive function is typically thought of as originating in some sense in the front of the brain, because, like you said, damage to the front of the brain. In particular, people who had had lobotomies back when that was created and that was legal and stuff, people volunteered to undergo those horrible things. Largely from studies with people who had had lobotomies, lesions of the frontal cortex do kind of create these situations like that. The classical one is, you know, the guy who's a businessman and then seemed to be totally normal until they noticed at meetings he would go and urinate in a plant in the back of the room. Yeah, that's normal. But so that's where it's thought to originate, but based on things such as fMRI studies, it looks very much like it requires input from the rest of the brain. In particular, there's regions of the brain associated with kind of salience, you know, your sense of, how would you, it's kind of hard to describe, like salience?
Yeah, so like what presents itself as an important stimuli?
Yeah, kind of like what's important, what to focus on, and those are very influential. So it's not just like a goblin sitting in the front of the brain pulling levers. It's this kind of integrated thing through the whole brain.
I think that's fair. I'm sorry.
Yeah, like I was going to add, like when you're very young, sound of the air conditioner. And so you just stop paying attention to that as a really salient stimuli. And it's still happening, but that sound, that tone, as it makes its way through the lower levels of the brain into perhaps conscious awareness, it is stopped. And that sensate is not made conscious. So the saliency thing.
I was just going to echo, I think, a lot of what you were saying. It's recent sort of investigations are seeing, it's not like the consciousness is in one location, like a seat of a soul kind of concept. And it's the binding problem, right? It's considered the binding problem.
Yeah.
What actually, that's what they call sort of consciousness. Where does consciousness come from? What binds? I've always had a tough time describing even the binding problem, but it's consciousness.
Yeah.
Is like what actually binds the physicality of this to the consciousness. And the more and more you sort of look at these imaging studies and actually start poking and prodding, sometimes in people, you start seeing that it's not necessarily just a locational thing. Because yeah, you take out the frontal lobe and certain functions are gone. What if the frontal lobe was an important node in the circuit, a pathway? So you take that out, you'd sort of see the same thing. It's very much a distributed kind of the brain is, what's that buzzword? The cloud. The cloud, everyone's considering the cloud a buzzword these days. It really is this diffuse activity. And you get rid of one part of it, you're a different person, but you're still potentially conscious. And it constantly changes, and it's definitely a network activity level thing. I'm sort of staking my career on that. It's a network connectivity thing and an activity thing, not so much a location thing.
Actually, you can lose almost all of your, even though the neocortex, the outer layer you can think of on the pictures, is most associated with most individual conscious experiences, you can lose all of it and maintain consciousness, whereas the brainstem is actually seems to be less associated with specific types of processing, but if you lose even a small part of your brainstem, you're unconscious or potentially dead if it was related to respiration or heart beating or something. So that's kind of paradoxical too.
Yeah. So I want to get into some of the stuff dealing with the social neuroscience, but I think we've got a pretty good idea of how how the brain makes this that we experience, but not really a very sufficient one, which is why there are people with another $10 million in this room. Please support funding.
That should cover one lab, right?
Right. Yeah.
Just one for microphone.
Probably. I give it to you. Social neuroscience, going into some topics. Edward Wilson, this great, a guy who's talking about evolution and what is it to be a social person, talking about humanity and so on, and also, in this case, talking about what human beings are doing. Put forth this idea about the connectivity between each of these human endeavors and larger systems, going from mathematics, physics, biology, neuroscience, ecosystems, social psychology, cognitive psychology, and tying all these together in order to arrive at these larger structures. What we're dealing with, humanities, is this link here between, when you're going from biological scales into neuroscience, and then moving into, the social aspects of individuals and cognitive psychology. It's really tough. How do you make that jump? Fortunately, things go back and forth. So there's a lot in social psychology that informs questions in neuroscience. There's a lot of neuroscience questions that inform questions in biology, so on and so forth. There's this interrelation between each of the different scales, and it's not as though one is naturally this or another. In this human knowledge, we're trying to identify how these things continue back and forth. So it's an interdisciplinary field, uses methodologies from both the neuro and social sciences to better understand the biological mechanisms that underlie social processes and behavior. Holds that this multi-level analysis can enlighten both social psychology and neuroscience. It's a new field. Tools didn't exist before. So, I mean, you could examine people with head trauma. That was one of the ways in which to understand neuroscience. I mean, there were some primitive, batteries that you could do experiments and healing people's headaches, but social neuroscience, fMRI, pretty new stuff. So yeah, we're getting into some of these rather detailed questions. EEG, one of these great ones. How does it work? You take electrodes, and as we were talking about before, with these charges moving in the brain, large amounts of charges will move in synchrony and cause these recordable, cortical signals that you can measure at different spots on the scalp. You can do some fancy math in order to identify where they're coming from. And you can do some things like repeating the experiments in order to see, what is happening uniquely within an individual experiment to cause changes in this firing pattern. Great for temporal resolution, it's electrical charge, but it's really terrible for spatial resolution. You can't get unique the cortex unless you're doing an experiment that opens up the brain, or opens up the skull. So it has its limitations, but it's really great. A lot of people use it. It's pretty easy to use, it's cheap. PET, not so used anymore, but you may see some of the stuff about this. You put radioactive dyes into a person, and these radioactive glucose itself emits radiation into the tomograph that finds out where this radiation was emitted from. Typically, the glucose is going to a particular part of the brain that's feeding from it. And so you can identify what parts of the brain are most metabolically active for a given state. You can also radio label other things, neurotransmitters, to find out where are these neurotransmitters being used. MRI, big magnets. It takes individual atoms and molecules and polarizes them, puts them, polarizes them, and then identifies via radio waves, what information is pinged when you ping these atoms with the radio waves and where they're located. You can get some really detailed images from this, and this has been really great because now you can see into the brain. You can get these 3D images. You can also start looking at differences between this deoxyhemoglobin concentration and the oxyhemoglobin concentration that is a contrast agent for these elements that you're pinging. So you ping them, it has more deoxyhemoglobin next to it, it's going to produce a different kind of signal that it has more oxyhemoglobin. And you can identify by that. These hemoglobins are in blood, and when they're oxygenated, that means it's fresh blood. When it's deoxygenated, that means it's been used. So as blood courses through the brain, you'll have fresh blood coming in where it's being used most heavily, and that is where the site of the activity is. And so you can start patterning, what's going on in the brain. The temporal or the spatial resolution, you get the full brain. You can get around to a millimeter. You can get to under a second per scan, full brain. So the spatial resolution, the temporal resolution are getting pretty good, but it's still, temporal resolution is still really slow compared to 25,000 hertz in EEG, whereas this is 2 hertz. So temporal resolution is kind of slow. TMS, another one of these things. In this case, it's actually interacting with the system. You can start stimulating parts, and that's really cool. In the awake, behaving person, a normal person, you can start making the brain fire and doing different firing activities, or not firing. or causing temporary cessations of activity. And so now you can do experiments where you're looking at individual parts and seeing whether or not this particular location is involved in this behavior or not by influencing it, as opposed to influencing the external circumstances. So you can start to do some more robust experiments with that. So yeah, this is social neuroscience. It's all happening in the brain, and we're trying to figure out how these very social issues now that we can image them, are occurring. Beyond this, there it is. But there it is. It's happening in the brain. Moving into what are the neurocorrelates? Where are these different things happening? Why are they happening in this particular location? What does it mean that, as we'll get to, seeing people from other in-group out-groups ignites the amygdala, this fear sensory area? What does that mean? So there are a lot of, you're creating a map of the social space in the brain, a physical map of the social space, that you can then navigate via different experiments to see how the brain is organizing itself, its awareness in these different social environments. Other tools, we got a lot from animal models. You may see some of this, maybe not. So neuroendocrine stuff, you may see some of this, androgens and estrogens, different chemicals in the brain, oxytocin, vasopressin. Oxytocin, which you mentioned, is big here. It's interrelated molecule that loves serum. So big work over here. Corticosteroids too, big work over here in this HPA axis, the stress axis, and depression and so on. Involved a lot in depression. They're regulated, upregulated, dysregulated. Clinical patients too. Great source of information. So social neuroscience in action. First, I want to get some impressions for us to get into during the symposium itself. What sorts of biases and stereotypes, positive or negative, do you experience? I, for one, find it kind of difficult to navigate my need to impress only white males. I find that kind of debilitating. There are a lot of people here, but white males have a lot more money than everybody else and a lot more influence. So I find myself genuflecting and bowing, all this other kind of stuff. So that's it doesn't really make sense on an implicit level. But there it is.
Did you see the founders at the dedication ceremony?
No.
They were pretty white bread, I thought. Yeah, so I can understand that, even if I am a white male.
Something about like their experience, I guess, at the university, and I don't know about maybe kind of works, but I know that maybe they, I guess every community wants to make everybody feel inclusive, and I know that I have a very unique experience. I think I could talk without the microphone. But anyways, but I was talking to a friend who, again, is peripheral to the community here, and we just happened to be eating at a restaurant here, and we're getting like relatively bad service, and I was like, oh, this is weird, He's like, no, you don't understand. I thought it was just like something weird, maybe they're too busy, maybe though they weren't, just kind of thinking it was a outlier in the, I guess, the experience of eating out with a friend, but he's like, no, that happens to me all the time. And again, it's kind of going back to what you mentioned, is sometimes I guess people are perceived as being outside of this community, and maybe there's actions that are different to them, whereas if you're seen as being inside the community, you're kind of just automatically accepted and there's really no question asked. And I mean, that's a problem that exists in all communities, if you think about it. So that's definitely something that occurs, again, like in all communities, and with this symposium, and I guess the discussions we're having here, we can see how we can move beyond that, hopefully.
building is actually from the 50s, and there were only men in the geology program back in the 50s. So there are not enough women's bathrooms. There's only one women's bathroom in the whole building, and there's 3 men's bathrooms. So that's my personal experience.
I was having a conversation with a student this morning about bumping up against other people's stereotypes, particularly around class at Emory. For her, it was the experience of people projecting a certain family life into her history, which she didn't have, or a professional background for her parents and things like that. I had the same thing when I was here as a graduate student, of people just kind of automatically assuming that I went to a good school or something like that as a background, and I was a scholarship student at Ohio State and worked 3 jobs and lived with my parents. So I had no, it was always very interesting whether or not I outed myself or just passed, and that was a very, has been a common experience I've found for a lot of my work study students now, is whether or not they tell anyone that's not my life. I did not get a car for my 16th birthday, you know, like, my parents are not doctors, things like that, has been, that experience of bumping into assumptions, other people's assumptions of privilege is very interesting.
So I'm like the first Latina in the philosophy department, so there's lots of bias that I encounter all the time, but beyond that, one thing that's a real problem, particularly talking about knowledge, is that what gets studied in the department is extremely biased, and what's considered to be knowledge worthy of being studied is extremely problematic. So it's not just our experience here, it's also our experience in the classroom, whether we get talked over, who gets to answer what experience you bring to your undergraduates that are in the classroom.
Something going back to what you mentioned earlier about passing. Again, I don't know, maybe it was my youth. I just didn't realize one of the things, there was social neuroscience involved in my life, and I've fairly recently become aware that again, having this conversation with a friend where we're both Hispanic people, but we both look different. But because I look more white, again, there's assumptions made about me, but he doesn't look white. So there's assumptions made about him, because he's a male, there's that added dynamic. But, you know, I've realized that I've passed, and now I'm also kind of feeling, you know, maybe what your students felt or what you also felt, was that should I allow myself to pass, or make people aware that, no, I mean, I think people realize by the time I start talking. But anyways, you know, there's that, that feeling, or that, you know, you're confronting people's assumptions, and do you allow people to continue assuming things about you, or, you know, confront them?
That's a good question. Yeah, I mean, moving forward, this particular talk as a primer in social neuroscience is really to get people to be able to get in with the conversation that's forthcoming. There's, you know, of course, there's stuff coming up about the information that's already available, but what you're talking about as far as how to move forward with it, you know, we're living now. This is the state of, you know, of certain salient processes, and there are other salient processes, and so on and so forth. How do we, you know, develop a different group dynamic? I mean, definitely. I see some people starting to head out. Yeah, so this next talk on the 5th, I want to say? 5th. It's a big poster. 6th. On, from the sociological perspective, really get into more of this moving forward. Interestingly, from a science, or a hard science, you know, we're mostly descriptive, saying what's happening in different situations. You can get creative and say, if I do this manipulation, will I see some great thing happening? And that's true, but you know, a lot of it is descriptive of what's going on. Yeah, that is what's coming up. I did want to see if querying other people have some statements.
Just, about bias, like just sort of approaching it from that, neural network to social network. What is bias? Why does the brain bias in the first place? Why I'm going to say something. It serves a function, right? And in certain instances, it's a bad function. In certain instances, it's a great function. I'm biased against semis because they might run me over when I'm walking. So when I am in the middle of the road and I see a semi coming, I'm going to go and say, hey, I don't like you. I'm going to get away from you. So, what is the function of bias in it? And I'm particularly fascinated by this in the network level. Where is it encoded in the network? Is it in the individual connections? How does it shape the sort of evolution of that network? And all of this builds up to, why do we make biases? Why are we so prone, all of us, so prone to make biases? And really analyzing that from, I think, from an evolutionary perspective, from a social perspective, is very important to A, get rid of the bad biases, B, understand the biases that we have, that we will always have, and then, C, let me make something up. There are probably plenty of other things, but mainly those two. I feel like really analyzing it from that base, that's the role basic science has to play in policy, in sociology, in philosophy, and all this kind of stuff. I think it's an important, it's that bi-directionality that you mentioned. It needs to be that bi-directionality from neuroscience to all these other fields.
Because a lot of it really is that learning that we were talking about before, from development, the first couple of years of life, what is relevant to the life that you're living. And when you learn those things, those are the things that become crystallized during adolescence in your brain, and that becomes your personality.
But you have plasticity up to a certain point, and when you lose that plasticity, you lose the ability to get rid of biases that are no longer true, or that were never true, and you just had to have that for when you were young.
I guess I'm really interested in this idea that there's kind of like I'm not sure if there's any evidence behind it, but I do diversity work, so this idea that while you might have an initial kind of knee-jerk response of bias, that if you become aware of your biases, right, that you can, and so the classic example is, a white woman walking down the street may see a black man walking towards her and clutch her purse a little bit tighter as an instinctual bias, right? But she may also then realize that that's what she's doing and realize that that man actually isn't threatening her, right? So I guess I'm interested in that process and if that's really true, and is that, are we talking about, some kind of, I don't know if it's an executive function or a higher function or a meta function that's coming down and interpreting these more instinctual.
Yeah, but very much so. And I'm not sure if they're on these slides, but in looking at those very questions, when you have individuals who are internally motivated to affect their state of mind, those internal motivations end up enabling processes in the brain that recognize that there is some dissonance in what their intentions are and what their actual experiences are. Seeing that, perceiving that, and enabling through executive functions the alteration of the behavior of the individual, the thoughts of the individual, more so than individuals who are externally motivated, who for some reason are just urged to do that. So you're seeing experiments that are on that level, detailing particular experimental paradigms and finding out how those interactions are mapped into the brain via different ways, via these different tools. So yeah, very much so. It is this constant process.
Yeah, on the cellular level, it's a little controversial. This is pretty new, but recent evidence suggests that most of the plasticity goes on in inhibitory neurons and interneurons. So in some sense, it may be easier to
prevent a bad behavior than to never have it in the first place, from neurological.
Or does the plasticity only working in one way? Is it just an increase of inhibition, or do you have loss of inhibition? You know what I mean? Like,
Yeah, you could have both.
you could have both.
Yeah. I guess by inhibitory here, it means more a type of neuron called inhibitory interneurons. So this would mean some kind of pre-planned motor function, or maybe something, like you said, since you've done since a young child, would be more difficult to remove than adding another layer on top of that of inhibition. It's kind of like an additional layer, step in the process, like you said, you know, not losing the urge,
But being critical
of it.
Yeah.
And it is really through some of these experiments that we get a toehold on how our innate biology can inform our intentional, actions in order to change our ways of looking at the world. There are a lot of experiments going, talking about this amygdala and racial groups and all this other kind of stuff. In this case, they're looking at in-group versus out-group stimuli and the amygdala, and some of these year 2000 topics. At the outset of the experiment, all amygdala activation was happening for every group. You see a face, who is that person? Afterwards, start to categorize, like in-group versus out-group. This person is in a perceived out-group. The amygdala activation remains, maybe even intensifies. Whereas if they're in a perceived in-group, and you see this person again, the amygdala activation softens. So the amygdala. So I think we want to tell what the amygdala is, but here's some pathways that people have found. In operation, visual stuff. The thalamus, of course, the center of the gate perception, to the severe sensing container.
For the racial in-group versus the racial out-group, are those studies a lot of times, are they studying them along strict two races lines, or are they, because I would think just embedded in like embedded in the US, there are really strict things that are impacting that, so it's not necessarily race or skin color as much as it is culture that's taught from such a young age that it's not.
I mean, you look at football teams, and you go to a different school, and then now you have a different football team, and so everybody's in the football team, and so it doesn't matter anymore. You're in a different in-group. It very much is your environment and who's funding it. A lot of the funding is for this American racism, which has its own goods.
Have there been any studies of similar groups, say in the U.S. and Canada, which have very similar sorts of cultures, but very different histories of racism just structurally?
I'm not sure about Canada, but I've looked into some of the work looking at people in the Far East. There are a lot of people in Michigan, University of Michigan, who are looking at these types of cultural differences and analyzing these questions, looking at whether or not our impressions about individualism versus collectivism are met out in the brain. So depending upon who's conducting the experiment, you'll find different paradigms at play. Certainly in Canada, they're looking at Canadian issues. Absolutely. And to speak to that, yes, there is a greater amount of collective mentality for people in the Far East than in the West. You can see that in some cool experiments looking at a 5 made out of individual 5s. Do you recognize the individual 5 or the larger 5? And I didn't even say that in a group way of saying it. And it really is just looking at these different paradigms. Race evaluation in the amygdala and these different ways of looking at black faces or white faces, similar experiments. EEG measures. This is mostly white people in this experiment looking at the event-related potential. I did want to get to this because it's a different paradigm. Most of the other stuff is up and around. This is event-related potentials. After a number of different trials, they ended up isolating this activity at the instance of presenting an image and found the difference between when looking at either an African face or a European face, and found that there was a difference, a demonstrable difference between the amount of similar neuronal activity activating simultaneously, depending upon the two targets. Same thing with male and females. This is mostly European descended males. Really with these, hopefully the discussion that we've gotten into is still in our minds. I think this was the kind of point that I wanted to make with it, that of the nature of the investigation through neuroscience and how that's supported based upon some of these fundamentals. People, I guess people are still sticking around. I guess it is 5:30. So we'll go through some of these and talk about them if you want. I look forward to the conversations coming on December 10th and bringing your inquisitiveness and your urge to create a better tomorrow.